This is Expert Honda and you are watching on the YouTube. So let's start and see to the questions that we have is 72 of the Leetcode question, that is edit distance. Given two strings, word 1 and word 2 we have given, and we have to return the minimum number of operations required to convert word 1 and word 2. So you have the following three operations permitted on this one, that is the insert, delete and replace, right? So either you have to insert, you have to delete, or you have to replace. Okay, so what you have to do, either any of these operations you will use, and now you have to count these operations, how many operations you have applied. Let's suppose insert you have applied one time, delete two time, and replace one time. So total how many operations we did? Four operations. You have to return this answer. Okay, let's see the example one, and the word one we have given and word two we have given, right? So what is happening here is that first of all, we are taking the word one, right? This word one is here, right? So in word one, what we are doing, we are replacing h with r, and so now horse is going to rods. Okay, now we have to reapply on the rods, and we will remove r from here. Now it becomes rows, right? Now from rows we have to remove e, so it will become ros. Okay, so finally if you see that we have first called remove, sorry, replace, then remove and remove, right? Two times remove, one time replace, total three times operations we have applied, so total three operations we are returning as output, right? Now understand, we have another example, that is example 2. We have word 1 and word 2 we have given. If you'll do the iteration, if you'll do the operations on this intentions, right, what you will see, you will have to apply remove, replace, replace and insert. Total 5 operations, that's why we are returning the answer 5. Now the constant we have given is word 1 and word 2 have the length, it can be length can be from 0 equal to 0 to greater than equal to 500, and it consists of lowercase English alphabet. Okay, now think that why this question is so important that we are going to discuss, because this question has been asked in hang, right? Approximately all the companies had been asked these questions, right? Major companies. So this question is related to dynamic programming, DP, and you can say strings too, right? So if you have already seen these questions patterns, right? Either you have seen in the one distance, one edit distance, or a delete operations for the two string, or a minimum sky delete some from two string, right? And these are the similar questions that we have already may already have seen in our past life, right? So what you can see that we can follow these questions later. Before that, you implement these questions, right? So if I'll talk about the approach, right? So first of all, the edit distance is a term used in computer science. By the definition, edit distance is a string matrix, right? And a way of quantifying how dissimilar to a string is, right? Let's suppose we have given two words are different from each other, right? And that is measured by counting the minimum number of operations required to transform one string to another string. You can see the Wikipedia, you have the everything is there, right? Now understand, uh, if we are going to use this operation, this approach, that is uh, approach one, that is recursion approach, right? So in the recursion approach, what we will do, first what we will do, let us start by first identify the ground rules, like two string we have given, right? Word one and word two we have given, right? So what we will do, so if the two string that is coming in the word one and word two are the same, right? Then what we will do, we will edit the distance is edit distance is 0, right? So for that, what we will do, we'll check this one. If both are these ones, like what's index, we will see later. Wait, wait, sorry. Okay, so what I'm talking about, like we have given two word one and word two, right? So the first thing is coming in our mind is, if two string are same, right? word 1 and word 2, word 1 and word 2 both are same, right? Means we have to return what 0 we have to return as a output, right? So edit distance is 0. Now we'll consider that one later. So word 1 is equal to word 2 and no need to add, remove or replace any character, right? Next is coming if it is not equal to, right, not equal to this one, then what we have to do, we have to use operation plus you can say delete, right, and then replace, right, replace. So we have to perform if and only if a character at a certain position in word 1, right, in word 1 is what we have is not equal to the corresponding, right, that we have already seen, right? So horse and another thing, right? So what we consider here is, let's suppose we have what, we have two things, we have in word 1, let's suppose in word 1 we have ABC and word 2 contain ABE, let's suppose, right? So here if you see index by index, this index 0 is equal to index 2, index 1 in word 1, this index is equal to this index, right, and but this is not equal to this here C and E, right? So the words are not the same, right? If you check the characters, right, the positions, you will see there is difference, right? So in this case what we will do, we have to perform some operations in the word 1, right, obviously, to transform it into word 2. And if we'll talk about like let's suppose what we will do first of all, what we will do, we will delete C, we will delete C from here, and we will what we will do, we will insert we can insert into this as a E, right? Let's suppose we are inserting into E, right, we are deleting C, inserting E, right? And now what we have to do, let's suppose if we'll talk about what we will do, delete C from word 1, we will write here A B, we have removed, right, now it is AB. Now what will happen after deleting C, what we have did, we have deleted C, now it become what word this is word 1, right, this is word 1, now word 1 is AB. Now we have to insert what, let's suppose now we are inserting E, after inserting it become ABE, correct? So now we can say we are doing this one, right? Or either what we will do, we'll do direct replace ABC will become ABE, here is only one replace, right? So here is two approach. The first approach that we have seen is we are using the approach in which we are using what, we have used delete and then we have used insert E, right? So this is approach 1, and there is another approach that we have is this one, correct? So in this way what we will do, we have the goal to choose the option, right, which option we have to use to transform word 1 into word 2. So we can apply the minimum number of operation, right, and we'll say how can we do that. For that let's we have to try to perform one by one, right, that we have did, right? So in this way you have to check like which approach we have to use, right? And so that it's very clear that option 1 and option 2 that we have did, right, that first what we have did, we have deleted and then we have inserted, right, we have here. And in the third operation what we have did, we have just did one operation, delete, update, replace, right, this one. Now so in this case what we will do, we will choose option 3 because it is taking one, and it is taking what, 1 1 2, two operation is here. Obviously we have to choose minimum one, not this one, right? So what we have to do in this case, we will take what we can say, uh, we will take always minimum, right? So what we will do, we will create one minimum recursion function, right, word 1 word 2, then we will pass both lengths, right, word 1 and word 2 length, right, and we'll create one minimum distance recursion, right, and then we will pass word 1 and word 2, right, and then this is the index of the both word 1 and word 2, and we'll check one by one character just as we have checked first AA, then there is a BB, right? And the last one we have the index at 0 1 2. So at index 2 we are getting C, and here we are getting E, right? So what we have to do, we have to check index, each index, right? That's why we are passing index of both you can say index, right? We'll check at index. If word index is equal to 0, we will return the index, right? Both at both places, right? If index is 0. Now what we will do, first of all we'll do the minus word 1 char at this index minus 1, right? If index minus 1, we are having the character, right? So we check the character of word 1 and word 2, right, of that particular index. If equal, then we will continue doing what index minus 1 and what index minus 2, just we're reducing one more index, right? So one by one character we will check, and we will find equality. If this is equal, then it will continue. Like first we will check AA, then it will check BB, and then it will reach to CC. Okay, like that we will move. So we are starting with the last length, right? Last length means we are starting from the last one, and then the length doing minus minus one, so it's become you can say index. When we reach to the last first index, then we will get this one. Just we are doing reverse one, right? Reverse from the last position to first position. Now what we can do here is or if you starting from, if you're passing 0 0 index, then you can do what, index plus 1 index plus 2 index plus this one, and you have to reach the last position. Then you have to make condition that at the last index we cannot move to the next one, right? The better approach is you will use the index minus 1 at each time, and will pass the length here directly. Okay, so I think you will understood this one. So now what we will do, if this is equal to, if character not equal to, like we will get in the words word 1 C and word 2 will get E. In that case what we will do, we'll check insert operation is required, delete operation is required, or replace is required. Which one is required? Any three operations we have, so we will do this one, right? Insert operation, delete operation, replace operation, we'll do this one. And then what we will do, we will find the minimum of delete and replace, right? And over that we will have our insert, right? And whatever will come here, that will, which one is minimum, that we have already seen, right? So first we have taken what, delete and insert. So we'll put delete and insert, right, operations, or replace operations, and which will come minimum, that will be our answer. But in this case what will happen, you will get you can say time limit exceed operations, right? Time limit exceed of operation, right, in the Leetcode, because this approach is little lengthy, right? And it will, we are taking each by each characters, and it's very tough to get very fast, right? So what we will do, you can understand the complexity, right? So if word have length k, right, let's k is the length of the word 1 and n is the length of word 2, right? So what we will do, so we have to take the maximum of k and n, which one is called let m, right? So time complexity become O of 3 to the power m, right? Because each time we are checking each pairs, right, for the word 1 and word 2. So it's very it's become a very lengthy exponential things. That's why we are getting the time limit exit, right? And the possibility that we if character are not matching, right? So in this case, the three possibilities there: delete to do the operations, delete, insert, and replace. And in the worst case, if none of the character match, then what we will do, we have to update all the values, right? So in that case, what we have to, all three operations we have to use, and in that case we are getting O to the power O 3 to the power m, because three operations we have, right? And for the space complexity, O of m we have to do, right? Because each call stack we have to store, right, as a depth of that, as a depth of tree, you can say, right? As you can see. Now think about the memorization, right? Why memorization is required? If you draw the previous approach, right, that we have did, right? So in the previous approach, what we have did is we are checking each by each value, right? So so far we have discussed the recursion solution in the approach one, and the solution works well, but it's very pretty exhaustive, you can say that, right? For further understanding, so what we will do, we will see this tree, right, and we will try to understand, right. So if you will take a pen and paper, and if you will try to draw the recursion tree, right, of the approach one, you will do the recursion like this one, right. So what we are doing here, first if you see, right, we are repeating here, we are repeating each time, right, like here, here. And if you are if you will see, notice that each time we are repeating the things, we are repeating here, we are also repeating here, right. And if we have already prepared this one, right, if we have already did this, so we should not use this again and again operation, we should not operate this operation again and again, right. So there is a substring combination of word 1 and word 2, right, that is evaluated multiple times, and that is highlighted, you can say, there is a highlighted, right. So in that case there is no need to do the calculation again, repetition again, repeated computation again, you can say, right. So can we find a way to optimize these recursive calls, right, and that's called dynamic programming, right. So if we can find that a certain sub problems that has been computed before, we can reuse that result and terminate it, you can say. For this we must store the result of every computed sub problems, and in a way we enable the algorithm to cache or memorize the result of every operation, so that every time before computing the result of for a problem, we can look if the result is already present in the cache, right. So that's bring us to understand a widely used programming thing, that is dynamic programming. And in this approach, right, we will use the top down dynamic approach, right. That is very very useful, and it's also known as memorization, right. So what we will do, let's try to look at the algorithm to implement this problem, right. So to do that, what we have to do, we will use top down dynamic approach, right, and it's a very easy, right. So we will do we will add some caching for the recursive call, we will store that one, right. And to do that, we have to take what memo, that is, you can say, this is our caching. We will cache our calculations, that sub problems, recursive functions calls, you can say, we here, right. As you can see, I'm storing this, I'm initializing this one as here. First of all, I'm initializing based on the given words length, right. So words length is here and here. So as a you can say matrix, we will have like this as a tabular form, right. The memory, that is our memo, you can say. And once this is initialized, right, then we will do the recursion. This is a function that we are calling, right. We will pass word 1, word 2, and its length we will pass, so that what will happen, we will calculate the this function, and will store the memo, right, at this time. So as you can see, we are storing here the minimum distance we are storing for each calculated index, right. And so that we can say, if this index is if we will try to implement again that one that we have already calculated, so we will check if it not any null, means we have already calculated, and we will return from the cache. And in that case it will get optimized, you can say, right. So your the calculator thing, no need to calculate again, we have in the cache, we will return from the cache, from the memory, you can say. So as previously what we have did, we will check the length, if the index is 0, we will return that index, right, uh, respective index. If word 1 index is 0, then we will return word 2 index. If word 2 index is 0, then we will return word index, this one, right. In this scenario we will continue this one. If that particular index we have already calculated, we do not need to do again, and we will get from the memory. Now we'll take a minimum distance, that will say 0, and we will check one by one character. If character is equal to this, then we will continue doing the minimum recursion. Then we will check the next character at that index, like we were talking about a b c and a b e, right? So if this is equal, we will continue doing the recursion for the next character, and for that we will use this if condition. If let's suppose if c and e, c is not equal to e, in that case we will come to here and we will do insert, delete and replace things, right? And here you what we will do, we will find our operation which is required here, right? And we will have our minimum distance, right? How we'll get this minimum distance? Previously you saw that already. So we'll do delete operation and replace operation. Which one is minimum? That will take, and another will take insert operation. Which one is minimum? That will cover our minimum edit distance, and will store this minimum edit at this, because this index is we are passing for this index. So in the memory we will add, and finally we will return our mean distance, correct? Now if we'll talk about the thing, right? Here what we are doing, we are calculating the mean recursion, right? But our purpose is not to find the do the minimum recursion. What we, our purpose is to find what minimum recursion, minimum distance, minimum our purpose is not to find minimum recursion. Our purpose is to find minimum distance recursion, right? As you can see. So each time we have to update our minimum edit distance, right? And finally we will return this one. Okay. Now coming to our complexity, right? So our complexity is what we have is, if word have m and n for the length word 1 and word 2, so it will become o m into n, because we are storing into the memory, and for or as the memory optimization happened for the cache, for every combination of word 1 and word 2, it resulted into at least one time, and so that we can say m into n times we have in the worst case. And for that this space complexity, we have to take one additional two-dimensional array that we are calling cache memory, and will the size is m into n size we have, right? Now coming to the bottom of dynamic approach, this is a similar approach that we have seen here. The only thing is that we will do from the bottom up, right? So in this approach we will discuss the bottom up approach by solving the dynamic programming problem. So as the name suggests, algorithm start from the bottom, and that is the smallest subproblem, and iterative computes the result of the larger subproblems, right? So in this problem the smaller subproblem is the base case, you can say word 1 and word 2 is empty. Then furthermore larger subproblem are built by adding a character one by one to each of the words, right? So the result of the a smaller subproblem can be used to compute the result of a larger one. For this purpose, what we will do, we must store the result into the DP, every subproblem into a DP array, right? So what we will do, let's suppose this is our DP we have, and for that let's suppose we have word 1 we have ABC and AQC, you can say. So in this case what we are seeing that first of all we will check the word length, right? Word length of word 1, and word length 2 for the word 2, right? So what we will do, first of all we have the base case, right? So we will check, we will use you can say a loop, right? And that iterate over the combination of input word 1 and word 2, and we'll find our edit distance, which is which we will calculate this one, right? So what we will do, we'll check if both are empty, right? If both are empty, then this is 0, right? But if there is empty, word 1 is empty and there is some character, right? So only one operation is required, that is called insert, and we'll have our minimum distance is 1, right? If we will have two operations here, like a and q, and word 1, let's suppose this is word 1 and this is our word 2, suppose. In this case what we have to update two operations. Similarly, if word 2 have three characters, we will have to do three operations, like that we have to do, right? So we have to maintain these tabulations like this only, right? And we will perform each time. Similarly, if we'll have word 1 have we have ABC, and word 2 we have empty, then only one operation is required, correct? Similarly, if there is one A is there and A is there, both are similar, right? There is no operations required, right? They will come 0. And similarly, if we have a and there is only one operation aq we have, so only one operation insert is required, will come like this. So in this way, in this fashion, you have to update this tabular, right? This will happen automatically, you can say that, right? As you can see. And similarly, what we will do, we will update our things, you can say. You got we have to update our tabular function, you can. So cache we have to update each time like this. Okay, now we are coming to the problem here, right? So first of all, we will check the lengths, right? So we will take two length, the word 1 and word 2, from its length, and then we will take our dp, and this is nothing but our cache. And this dp memory, we will have to our length plus 1, length plus 2 will have. And we'll check each length, if less than equal to this one, then what we will do, we will update our dp word length at 0. We will initialize its index, right? And similarly we'll check on the word 2, right? Similarly we'll go to the last index, right? And we'll update our dp 0 at word index. That we have seen, right? We are talking about this one, this one, and this one we are talking about, right? So similarly we will update this one, word 1 at this row, and word 0 at this 2, right? So only these two we have to update our it will update our tabular, you can say. Now coming to this one, once we have come, then we will come to the 2d, for what word 1 will come to the word 2, and we'll check all the character, right? Character at word 2 and character at word 1, if it is equal to, we will not do anything. We will go to the next, you can say, dp of index this one, and dp of this index 2. We will have our next dp, will update our, you can say, -1 index, you can say, will update. And if they are not equal to, right, then we will find our minimum dp index -1 into dp this one. And there is one more minimum we have to find, the dp at dp1 index and dp index -2. So this one we have to take a minus, right? And another is dp index -1, like this one we have to take. Which one is coming minimum, that will take here from here, and then we will store here. And which one is coming minimum, the result that we will have our answer. We'll do the +1, and then we will return our answer. Means let's suppose what I'm talking about. Let's suppose we have this one, right? So here you can see, first what we have here, we have dp, right? We are calculating dp at index this one, and dp2 index here, right? What we will do here, first we'll take dp index -1, dp index -1, and word 2 index -1, right? So if index 1 we have, right? So we'll take index, will come to, let's suppose we are coming to this position. Okay, so if this is our dp index, right? If this is dp index here, and here dp index 2 we have, right? There is a, and another is q, right? A and q. Let's suppose we have a here, let's suppose we are coming to here. Okay, what we will do, our word length we have, right? So we'll do index -1 and index -1 for both one. And for this one, what we'll have, word 1 index -1 and word 2 index -2. Whatever the data we have at this position, that will take, and we'll check the minimum, which one is minimum, that will come, right, in these three. And whatever the data will have, that will our answer will have. We'll do only +1 here. Okay, so in this fashion you have to update our each character, you can say. I think I've understood. If you have any doubt, please ping me in the comment box, right? And for the complexity, it will remain same as previous, right? So thank you guys, thank you so much for this session. If you'll come to here at the last, and if you'll find this video helpful, please hit subscribe and like this video. Thank you so much.